GMAT all day.
Let's do another word problem now involving circles. The GMAT loves to ask geometry questions using real-world situations, real-world items, and real-world shapes. And so this question says, in the figure shown, a 200-meter long circular track is inscribed within a square fence. Approximately, what is the area in square meters of the region within the fence, but not enclosed by the circular track? So what are they talking about? They're talking about the area made up of our four corners here. These four triangular looking things, but they're not actual triangles because their hypotenuse, each of their hypotenuses is this curvy thing here. So we cannot use our knowledge of triangles here. We're going to have to think of another way of doing this. So how can we find this area here? Well, we have this square perimeter around this circular track. And so if we can find the area of our square and then subtract out the area of our circle, that should leave us with nothing but our four corners. So how do we do this? We know this is a square. What does that mean? That means all of our sides have the same length. It also means all our angles here in our corners are going to be 90 degrees, but I don't think that is going to be super helpful here. And then what else do we know? The only true piece of information we were given is that our track is 200 meters long. So what does that mean? That doesn't mean distance from here to here is 200 meters. 200 meters long means the distance around our circumference is 200 meters. Or you can think of it as if you were to cut this circle and then lay it out in a straight line, it would be 200 meters long. So that means 2 pi r for our circle is equal to 200 meters. Therefore, we can find the radius of our circle is going to be 200 over 2 pi, which is just 100 over pi. So how can we use that to find the length of one of the sides of our square? So we know our radius from here to here is equal to 100 over pi. Well, if this circle is inscribed within the square, then the length of one of the sides of our square should just be the diameter of our circle. So our x, which is also really our d, should just be 2 times our radius over 200 over pi. So if we're trying to find the area of our square, that is just length times width, or in this case, x squared. So that would be 200, not 200 pi, 200 over pi squared. We got to subtract out the area of our circle. That is just pi r squared minus pi times our radius, which is 100 over pi squared. Now, this is often the case with geometry questions involving circles, especially in real-world situations where you're going to have to estimate what pi is, because pi is approximately 3.14. But you should know sometimes you can get away with just estimating it as 3. I would say the way you gauge that is based on how spread apart the answer choices are. So in this case, it looks like our answer choices are pretty spread out, meaning we could be a little bit looser in our estimations of pi. I still say, though, it is good habit yet be as precise as possible, even when you don't have to be. But it does say approximately here, which is a keyword that we're going to have to estimate. So let's simplify as much as we can, and then I like estimating only at the final step, or once I've simplified as much as possible. So 200 over pi all squared, that's going to be 200 squared over pi squared. So 200 squared. That's 200 times 200, so that's just a 4 with 4 zeros. 40,000. So 40,000 all over pi squared minus, so now don't cancel out these 2 pi's yet. First, we got to square this guy. So we have pi times 100 squared over pi squared. So 100 squared is going to be a 1 with 4 zeros. So we get pi times 10,000 over pi squared. Then what can we do here? So it looks like we can cancel out a pi here, but maybe before I do that, I want to combine my terms because I can use this pi squared here as a common denominator with this pi squared over here. Maybe I'll just sort of rewrite this as 10,000 pi over pi squared. Before I cancel out this pi, I want to use this to combine my two fractions. So 40,000 minus 10,000 pi all over pi squared. And now I would say, let's start estimating. So what is 10,000 pi? So even though I could probably get away with estimating pi as 3, I just think of this as 3.14, 10,000 times that. Shouldn't be that hard because I just got to move my decimal spot 4 places to the right. That would be 31400. So this is 40,000 minus 31,400 all over pi squared. So what would this be? Now if I just maybe estimate this as 31,000. So 40,000 minus 31,000 just leaves me with 9,000. Then I could probably estimate pi is just 3 here. So 9,000 over 9 approximately. 1,000 E. Like that. The reason we can do that is because our answer choices are pretty spread apart. If they were closer, I probably would have to do some multiplying with this decimal here of 3.14.